Hey guys, this is a video key to the Module 2 assessment review. So I'm going to start out with number 5 here. Okay, so this is taking 2 to the 4th times 2 to the 7th. Remember that we have our product rule, so make sure you understand we're talking about the product rule. That says if you take a power times another power with the same base, that we add those exponents because you have this many a's as a base m times, and then you use a as a base n more times, so a total of m plus n times. So this is going to be equal to 2 to the 4 plus 7, and we know that that's 11. So our answer is 2 to the 11th power. Number 6 is 9 to the 0 power. If you remember from the activity and from our table, we have this as the 0 power rule. And that states that anything to the 0 power is equal to 1, except for the base being 0. So since the base is not 0, 9 to the 0 is equal to 1. And that's our final answer for number 6. Number 7, we're dividing, so we're going to use the quotient rule. If you remember, the quotient rule says that if you're taking a power divided by another power with the same base, that you subtract the exponent. So that's equal to a to the m minus n. Because we have, for this, we have 28s in the numerator and 5/8 in the denominator, so 5 of them will cancel out, leaving us with how many? So that's essentially just subtracting. So it's really 8 to the 20 minus 5, because 5 of them will cancel out, leaving us with 15 in the numerator. So our answer is 8 to the 15th power. Number 8 is 5 to the 3rd to the 7th. So notice this is not the product rule. And the reason it's not the product rule is because in the product rule, you have a to the m times a to the n equals a to the m plus n. So notice you have the base written twice. You're actually multiplying a power by a power. There's only one power in this problem, okay? One power with a base written. And so what we're actually doing is taking that power to another power. So this is not our product rule, but it's our power to a power rule. And that says that if we have a base taken to a power and then we take that whole thing to another power, that's equal to that base to the product of those powers. So when you multiply, or when you take a power to a power, you multiply the exponents. Because what this is really saying is, oh, I want 5 to the 3rd 7 times. So I'm not going to write it out 7 times, but if you had 5 to the 3rd written out 7 times, then you would have a total of 21 5s written out, okay? So 5 to the 3rd to the 7th is 5 to the 21st power. And that's your answer for number 8. In number 9, you can see that we have a negative exponent. So that negative exponent, remember, means reciprocal. So here's our negative exponent rule. That when you have a negative exponent, instead of multiplying by the base many times, we're actually going to divide by the base that many times. So a to the negative n is equal to 1 over a to the nth. So notice I'm still multiplying a n times, so ignore the negative. I'm using a as a base n times, but in the denominator, so I'm really dividing by a this many times. So with the 7, it's just replacing the a is the 7 and the n is 9. So 7 to the negative 9th is equal to 1 over 7 to the 9th. So instead of, if that negative wasn't there, 7 to the 9th power means multiplying by 7 9 times. But since the negative is there, we're still going to do that. Multiply 7 by itself 9 times, but in the denominator. Or you can think of it as dividing by 7 9 times. And that's your answer for number 9. Number 10 is another power to a power. Because again, notice we only have one base written. So it's a power to another power. So you're going to use our rule and multiply multiply the exponents. So 10 to the 8th to the 4th is 10 to the 32nd power. Number 11 is another example of the quotient rule. So remember, we subtract the exponents when you're dividing a power divided by another power with the same base. So when you're dividing with the same base, you subtract the exponents. So that's equal to 14 to the 7 minus 6, which we know is equal to 1. So it's equal to 14 to the first power, or you can just write 14 since it's just to the first power. Number 12 is 4 times 4 to the 8th over 4 to the 3rd. So we actually have two rules going on here. So you guys need to get used to not always being able to get the answer in one step. This is going to take 2 steps. So in this problem, since we have division, okay, when you have it written as a fraction, you always have to know what the numerator is, what the denominator is, then you can divide. So we actually need to figure out what the numerator is first. We need to condense that so it's only 1 power of 4. Now technically you can get around that, but for right now we're going to stick with that. So 4 times 4 to the 8th, we'll use our product rule since we're multiplying. So when you multiply with the same base, you add those exponents. So be 4 to the 9th. You got to remember that if there's no exponent written, there is a 1 there, okay? It counts. This is using 4 as a factor once and then 8 more times, so a total of 9 times, okay? Don't forget that. So it's 4 to the 9th over 4 to the 3rd. Now we just have a simple division problem, so we can use the quotient rule, which again says when you're dividing with the same base, you subtract the exponents. So this is equal to 4 to the 9 minus 3, which is 6. And that is our final answer. Number 13 is another one where we have 2 rules going on. So we actually have the power to a power rule and the quotient rule. So just like last time, and actually in this case, we have to do this first. Okay, there's no way we can do the division yet because we have the whole thing to a power. So we need to do the numerator first. So when you take a power to a power, you multiply the exponents. So 3 to the 5th to the 2nd is equal to 3 to the 10th. And we still need to divide that by 3 to the 7th. So we can go to our quotient rule and know that when you divide with the same base, you subtract the exponents. So this will be 3 to the 10 minus 7, which is 3. So 3 to the 3rd is our final answer for number 13. So that's all for this section with exponent rules. So you can go on to the next video to deal with scientific notation.